the one where I talked about forces on an inclined plane and tried to solve this yourself, okay? All right, so we talked about forces on an inclined plane. We talked about how the horizontal axis has now tilted. The horizontal axis, or the x-axis, is parallel to the surface, okay? And my y-axis is perpendicular to the surface. So now gravity, which normally just acts in the negative y direction, is actually acting at an angle, which is weird. And so we do things a little bit differently here. Okay. We needed to calculate how much force was acting on the object in the x direction. The only force acting on my object in this problem is gravity. There's no friction here. There's no additional pushing up the ramp or pulling down the ramp or anything. It's just gravity. So we only have to deal with gravity. So what you need to do, if you're figuring out how much of that force is acting in this direction here, you have force due to gravity as your hypotenuse. You know this angle is 25 degrees, and x is opposite that angle. So you just need to do the force due to gravity, which I calculated 5 times negative 9.8 is negative 49 newtons. Negative because it's going down. Then, when I figure out how much of it's going in the x direction, that is 49 times the sine of 25 degrees to get this opposite side. I get 20.7 newtons. Now technically, if we're thinking about this as my x-axis, this is pulling to the right on the x-axis, which we consider the positive direction. So I'm going to go ahead and leave this as a positive 20.7 newtons, okay? Then with number 5, what I wanted to show you here was essentially to get the force that we needed for this problem, the force that was actually parallel to the surface. To figure out that force, I actually ended up doing force times sine times my distance. So you can kind of think of it if you've got, and this is really just when the force of gravity is acting on an inclined plane to move it down. If I actually reached over here and I pulled at a different angle like this, we would still want to use cosine to figure out how much was pulling this way. That would still work. But what I want you to know is if we're looking for that force due to gravity on an inclined plane, essentially you've got force due to gravity times sine of theta times distance will give you how much work gravity is doing on the inclined plane. That's a little g, it's not supposed to be a y. Here we go. So if I want to know how much work gravity is doing on an inclined plane, I can pretty much figure out like this. Okay, and that's why. From there, you should be able to figure out that, well, yeah, okay, if my work is this much, I did that times my 6 meters to get this many joules, then my change in energy should be this much. Okay? But what I want to prove to you right here, before we get to number 7, is that this is actually the same as calculating our force due to gravity. So what you can do is you can see that if I figure out my height of this ramp, we now know that the length of this ramp is 6 meters and the angle is 25. So if I want to know the height, I can use sine and figure out the height is 2.5 meters. And then if I actually, well, it's 2.53 blah, 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 blah. If you just plug in 2.5, you're not going to get exactly this number, but if you leave it, don't round it off, and you just leave the number that you had in your calculator and multiply that number times the 9.8 times the 5, you're going to get 124.2 precisely. And those are exactly the same. So it just shows you that when we're calculating the work here, the work done by gravity, that is the change in the gravitational potential energy. They're the same. And then the last thing here is just calculating power. It was 1 minute which is 60 seconds. There you go. All right, you have another video.